Okay, let's just quickly look at. Okay, so with this first one, they gave us cos 90 degrees minus theta, sin 180 minus theta, and then sin squared minus theta. Okay, so first we need to get to our reference angles. We can't use them when they're still in brackets. Remember, Botma says we must always get rid of the brackets first. So that first one, the numerator, 90 degrees minus theta. That puts me in a certain quadrant, and because of the 90 degrees, we've got a cofunction. Okay, so that's in the first quadrant. So cos is going to be positive, no? 180 minus, that puts me in the second quadrant. Sin is going to be positive. The sin of a negative angle is the negative sin of the angle, but we're going to see what happens there in a minute. Okay, so the top one changes to sin theta. Because of the 90 degrees, it's a cofunction. It's positive because it's in the first quadrant. The bottom becomes sin theta. Positive because it's in the second quadrant. Now, I've shown you this one step. It's not necessary for you to show this. That negative goes to the front. But because of the square, it's going to make that negative positive. And therefore, it remains negative sin squared theta. Do you all understand that? Okay? And 1 minus sin squared theta, in the first term, we could only do it up to there. But now we know our identities, and therefore it becomes cos squared theta. Who got it right? Good. Do you understand it, grade 11s? Okay, the next one. Let's look at it. 180 degrees plus. Which quadrant is that? Third, ne? What is cos in the third quadrant? Negative, so we keep that in mind. 180 minus? Second quadrant? And tan is negative there. And then the sin of a negative again, the negative will go to the front. So there are no 90 degrees there that will change into a cofunction. So this one becomes negative cos theta. This one becomes negative tan theta. And this one becomes negative sin theta. Do you all understand? Okay? So a negative times a negative becomes a positive, cos theta. And then tan I'm going to change to sin over cos. It's an identity. And then at the bottom I've got negative sin theta. Do you all understand? Okay, now you'll see there the cos and the cos will cancel out. And then I'll have a sin over a sin. And they will cancel out as well. And then I'll be left with negative 1. Happy? Okay, next up C. So here I see a 90 degree, and then the rest are just reference angles that I need to change the signs. So 180 plus, where does that put me? Third quadrant. Okay, 360 plus? First. 180 plus? Third. 90 plus? Second. 360 minus? Fourth. Okay, so now we just need to change the signs accordingly. So tan in the third quadrant is positive, so it's just tan theta. Cos in the first quadrant is first quadrant positive, so it's cos theta. Okay, at the bottom, sin in the third is negative sin theta. Cos in the second is negative, but then it changes to sin. Okay, do you remember that part? You first do the sign, and then you change to the cofunction. And then that one, cos in the fourth quadrant is positive, so it's going to remain cos squared theta. Do you all understand? Okay, now we can just simplify and work it out. So tan, I'm going to change to sin theta over cos theta. That I just put cos theta over 1, so I can see the cos's will cancel out. At the bottom, a negative times a negative is a positive. Sin theta times sin theta is sin squared theta. Plus cos squared theta. So the cos's at the top cancel out. And what is sin squared theta plus cos squared theta? It's 1. So I'm left with sin theta. Who got it right? Good. Okay. Okay, here it became a bit tricky where they gave us the angle sizes. Now remember, when the angle sizes differ, you can't do anything with it, okay? You can do nothing. You have to get the angle sizes the same. So our functions or our identities only worked when both angles were theta, or both are x, or both are alpha. One can't be alpha and the other theta. They have to be the same. So in this case, it's two different ones. Right. So I'm going to have to change that 112 because that's not an acute angle in any case. So it's not in its simplest form. I need to get it to its simplest form first. So I'm going to say 180 degrees minus 68. Now, please guys, remember, you'll see with the following questions as well. Whenever, like if you look at 112, you can either use a 90 plus or a 180 minus. But I told you guys to use the 180 and the 360 as far as possible. Only change to a co-function if you see at the end you need it. Don't decide beforehand you're going to need it. Just get it to an acute angle first and then you can make the decision to use the co-function. Don't jump to it. Okay, so 112 is going to be 180 minus 68. Do you understand? Which means this is in the second quadrant. Right? So it becomes negative cos 68 squared. But look, I again showed you the method here. The quadrant makes it negative. But the square makes it positive again. And then I'm left with cos squared 68 plus sin squared 68, which is 1. Who got it right? Okay. Okay, let's look at E. Like this one, we've got 3 different angles. Do you see that? 260, 100, and 280. Don't jump to a co-function. First, get it to a reference angle with an acute angle. So 260 is going to be 180 degrees plus 80. 100 is going to be 180 minus 80. So do you see now the angle is starting to repeat? So I feel like I'm on the right track. And then 280 is going to be 360 minus 80. Okay? 180 plus 80, which quadrant? 3. 180 minus 80, second. 360 minus 80, fourth quadrant. Okay. So now I can just change the signs. So that one is going to become negative cos squared 80. But because of the square, it changes to a positive cos squared 80. Sin 180 minus, that remains positive because it's in the second quadrant. But that negative was there from the beginning. Ne? Okay, the next one, 360 minus 80, that's in the fourth quadrant where sin is negative. So it's negative sin 80 degrees. So now what happens is a negative times a negative becomes a positive. Now I've got cos squared 80 plus sin squared 80, which is an identity. My angles are the same, so I can just write it's equal to 1. Okay, the next one, sin 70 cos 200 cos squared negative 70. Okay, sin 70, I leave it as it is. Now, the reason I immediately jumped to 270 is because I saw that the other two angles are 70 degrees. Okay, so then it's most easy. You don't have to be a brain surgeon. You can notice that you're going to need that one to be 70. So I immediately used 270 minus 70. Do you all understand what I did there? Everyone fine? Okay, and then that one, the cos of a negative angle is the positive, no? But then that square keeps it positive, but it doesn't change that negative. Okay, that is minus, that's not the negative. You understand the difference? Okay, so now if I look at it, sin 70, cos 270 is a co-function, so it changes into negative sin 70 because 270 minus is in the third quadrant. And then minus cos squared 70. So what happens now is I've got negative sin squared 70 minus cos squared 70. Now that's almost the identity, but not yet. But what I can do is I can take out a negative in common. And then I've got inside of the brackets sin squared 70 plus cos squared 70, and that is negative 1. Who got it right? Good. Because I'm going to do this activity with you. So please write down tan theta equal to 2 and then activity 10. Okay, so what I want you to see now is I've drawn the graph of tan theta on the board. Now they want to know what is the value of theta, right? Where tan theta is equal to 2. Now if you look on the sketch, you will see there's 2. You see it? So if I were to ask you to read the value of the graph, can you see that you would have more than one value? Because at this point, the graph is equal to 2. There, it is also equal to 2. There, it is also equal to 2. There is also equal to 2. Also equal to 2 and also equal to 2. And I only drew this graph for you from negative 1080 degrees to positive 1080 degrees. Can you see the problem? Okay? So I can't just give one answer. Okay? We need to give multiple answers. So do you remember when we started trigonometry, I showed you a lot of graphs. I told you that I'm going to explain it to you using graphs. And then I said that a sin graph's period is 360 degrees. It takes 360 degrees to complete a full wave. So after 360 degrees, the graph will repeat. It was the case for sin is 360 degrees, and the case for cos is 360 degrees. But for tan, it had a different period. Do you remember that? A tan's graph period is 180 degrees. That means the graph repeats every 180 degrees. So if you look at this value, let me show you here. This value right there. Do you agree with me? It will repeat after 180 degrees. And then again after 180 degrees. And then after 180 degrees. And also, it will be that value there minus 180 degrees. Minus 180 degrees, minus 180 degrees. Do you agree with that? Okay? So we need to find a way to write the answer that includes all of the answers. So I'm going to explain to you actually activity 11's work. You're not supposed to be able to do this with activity 10. I'm going to explain to you activity 11 and then we're going to apply it here at activity 10. Okay? Just to win some time. So if you were to do this sum, tan theta equal to 2, you would use your calculator. Do you remember in grade 10 we did these sums? It was so very easy. You literally just say shift tan 2. And then you get an answer of 63,4349. Okay. So I'm going to write down that answer. So theta is equals to 63,4349. I'm not going to round it off just yet, degrees. But as you've seen, that is not the only answer. If I take you back to the graph, that will be the answer of that value right there. But now I only have one of the answers. And there are infinite number of answers where tan theta will be equal to 2. There are infinite number of thetas that I have as an answer. So what we're going to do is we are going to write a general solution. Right? So what the general solution does is it includes let me just get it back up there. Let's just give it a second. I will talk to you so long. It includes all of the other values as well. Okay? So we are going to say theta is equal to this 63,4349 plus every 180 degrees after it and minus every 180 degrees before it. But you know, in mathematics we don't write sentences. So we're going to write it in an equation. Okay, so we're going to write it in a sum. Now let me just sort out this computer in a second.